Right. What if there is a mixture of saturated vapor and liquid? Okay, this is where actually you started to have a mixture of it, both. For example, if you go back to the previous slides, right? If let's say you only at this particular point, which means that you are 100% you have saturated liquid, and if you are at this particular point, you have 100% saturated vapor. But how about if let's say you are in the middle? So which means that you have a mixture of liquid and vapor at the same time. So this is where actually, in order for us to know what will be the fraction of vapor equivalent to the total, this is what we call as using the term quality. Quality, X is the ratio of the mass of vapor to the total mass of the mixture. So X is equals to M, mass of the vapor, divided by mass of the total. Okay? But can we distinguish that? I think that is also another challenge for us. Is, for example, like, what will be the mass of the vapor and what will be the mass of the total? Because looking at our eyes, we cannot see clearly whether it is actually we cannot see clearly whether it is it vapor or is it liquid, right? So we cannot simply just determine the amount of mass for the vapor or for the liquid. So quality is between 0 to 1. 0 is saturated liquid, 1 is saturated vapor. So quality has significant for saturated mixtures only, no meaning in the compressed liquid or superheated vapor region. So if you imagine this curve again, okay, if let's say we have this curve, right, and then you have from that particular curve, and then you have this this line. So the most important part of using quality is between this period only. Okay. So for example, it's supposed to be X. So for example, at this particular point, X equals to 0. At this particular point, X equals to 1. Alright. And another information that we should know here is the properties of the saturated liquid are the same whether it exists alone or in a mixture with saturated vapor. Because at this particular point, if you still remember, okay, this is, let's say, T versus V, and then you have this particular curve, right? And then you have a line here, okay? And then you have, this is actually the saturated vapor, saturated liquid, and this is saturated vapor, okay? So you start to see that okay, along the line here, the properties of the mixture of the liquid, okay, the properties of the liquid are not changing because it is actually on the straight same line. So which means that it is exists at the same temperature. What only change is what you can see is the volume. So this is Vf, for example, this is Vg. So along the way, what is changing, if let's say you are looking at this point or the other point, is actually this is what we call as it's just changing the volume, but in terms of the properties such as temperature, pressure, it maintains the same. Okay, it is at the same pressure and the same temperature. And here what it means here, temperature and pressure are dependent properties for a mixture. Okay. So what if again the continuation of the slide, a saturated mixture can be treated as combination of saturated liquid and saturated vapor. So if you can see from here, the combination of saturated vapor and liquid, it is actually the same amount as the what we call as V average saturated liquid vapor mixture. Since we do not know the mass, okay, as I said earlier, if you want to calculate quality, right, if you want to calculate quality, X is equals to mass of the vapor phase divided by M of the total, right, which is total between mass of the vapor and mass of the fluid. But what is actually happening here is we cannot determine the amount of mass. For example, like what would be the specific mass amount of mass for vapor? We cannot determine that. So we assume that the two phases are mixed well, forming a homogeneous mixture. So considering a mixture of saturated liquid and saturated vapor, the liquid has a mass mf, occupies a volume of Vf. The vapor has a mass of mg, occupies a volume of Vg. So this is where actually we're going to use the phase diagram to help us to determine what will be the quality. Okay. So looking at the next slide, I think this is the slide where we stopped last time. So the V average, okay, the V average is actually equals to the volume, specific volume of liquid phase, specific saturation volume for liquid, plus with XVG, VFG, which means that this is the quality multiplied with the difference between VG and VF. So if you trying to look back at the diagram here, okay, so VF, where is VF? VF is here, right? And then we are looking at X, VFG. So what is VFG? VFG is actually the changing of volume from this point to this point. This is VFG, right? Okay. Right now, how about X? X is actually somewhere around here. As I said, this is where the point X is equals to 0. This is the point where X equals to 1. So for example, X is somewhere around here. Okay, so at this particular point, you know that the specific volume at this mixture is actually higher than the volume for fluid, but lower than for the gas. Okay, so such a way that in order for us to calculate what is X value, when you rearrange back this particular equation, you'll be able to see that V average minus VF, okay, which is at this particular point, this is where actually we got V average. Okay, so V average minus VF, okay, divided by the total of this length, VFG. Okay, so this is where actually we'll be able to get to obtain X, right? So at the same time, if let's say we want to determine the internal energy or enthalpy, this is where actually you can just use similar formula. You just replace V with U and V with H. Okay, so you'll be able to substitute this formula, and you refer to the table, you'll be able to get UF. To refer to the table, you'll be able to get HF. And here you'll be able to calculate, and once you know what is X value, then you'll be able to determine your U average as well as H average. So a simple formula which you can refer to is Y average equals to YF plus XYFG, and Y, it can be V, it can be U, it can be H, enthalpy, internal energy, or specific volume. And you have to know that the Y average here should be in between YF as well as YG. Alright. So if you want to determine the property in saturated mixture, so let's look back at this equation. Okay, so when we start to relate with this diagram, what we see? So in order for us to determine the X value, is actually just a distance AB divided by AC. So if let's say the B points is changing to this point, which means that the V average minus VF is actually moving up to this point, and then divided by AC. AC is actually VFG. So here you can determine the value of X. Once you got to know the X value, then we can use any kind of equation. For example, like you want. Okay, so in order for us to determine what is actually the U, for example, okay, I'm sorry. Right now, when we be able to determine the X value, okay, so we'll be able to determine, for example, like you want to know the U average, internal energy average, or you want to know the enthalpy average, okay, enthalpy average. So by rearranging back the equation, so once we got to know the X value, you rearrange back this equation, then we'll be able to know what will be the U average, V average, or H average. Okay. So if you look back at this particular equation, X is equals to V average minus VF, which is the numerator. We call it as distance, and denominator is the length of the entire horizontal line, which is the length of this line. Okay, this is where we got VFG. saturated liquid vapor mixture states on PV and PV diagram. So you'll be able to see that now if let's say this is a vapor, this is for water. So if let's say you have mg as 2 kg and mf is 8 kg, so from here you'll be able to determine the x. Okay, so can you determine what is the x value? So x is equals to 2 divided by 2 plus 8, which is 10. So your quality x is equals to 0.2. Okay, so 0.2 may be somewhere around here. Okay, so in order for you to determine what will be the V average, for example, then we can just plug in the equation, okay, as I showed earlier, so that you'll be able to plug in the x value, you'll be able to know what is VF, and then you know what is VFG. VFG is actually the distance, the change VG minus VF, then you got your VFG. Okay, so from here we can determine your V average. Similarly, we can work out, for example, like to know what will be the enthalpy or the internal energy here. So for example, like if let's say you have the R134 refrigerant punya substance, pure substance, okay, and then you are at the pressure of 160 kilopascal. So from here, this is your point of saturated liquid, and then this is your saturated vapor point, and you wanted to know, for example, like what will be the value for here. Okay, so again, this is where you can determine your x, and after that you substitute the amount, and then you'll be able to know what will be the HF as well as HG. Okay, even H average, you can determine all these H average, U average, and so on.